Good morning, students. We started discussing natural numbers, whole numbers, and integers, and we'll continue the class. So, last class we have completed addition and subtraction of integers, and we took some examples also. And today we are going to discuss multiplication and division of integers. So, both multiplication and division are based on the same rules. Positive into positive, you're going to get a positive answer, positive integer. Positive into negative, you're going to get negative answer. Negative into positive, you're going to get negative answer. Negative into negative will be positive. That means you can remember same signs are multiplied, you'll get a positive answer. Opposite signs are multiplied, you'll get a negative answer. The division rules will be positive integer divided by positive integer, answer will be positive. Positive by negative will be negative. Negative by positive is also negative. Negative by negative will be positive. So same as multiplication, division also same thing. If you divide the same signs, you'll get positive answer. If you divide opposite signs, you'll get negative answer. So let's take some questions. Okay, all of you try these questions. So remember only one thing, the multiplication or division. If applied on same signs, the answer will be positive. If applied on opposite signs, the answer will be negative. So anyone interested to answer the first four questions can raise a hand. Mayuk? Mayuk, can you answer the first four questions?
So first I have a doubt.
Yes, Mayuk.
So first let's say to plus that one copy.
Yeah, you can copy because you need to remember those rules.
Yeah, I
Mayur,
can
can you
tell.
answer the first four questions?
Yes, sir.
Okay, first answer 2 into 3,
6
6. Second one, 2 into minus 3.
minus 6. Yeah.
Yeah, because plus into minus is minus. Next, third one,
Sir, minus 6.
minus 2 into 3. Read the question and say the answer.
Minus 2 into 3, 6. Minus 6. Yeah.
Okay, next one,
So minus 2 into minus 3 equal to 6.
6 or plus 6, both are same, right? Because we know negative into negative is positive. Okay, very good,
Okay, sir.
Mayur. You can mute yourself. Any other student want to give answer the next four questions can raise a hand. Shane, can you give the answer for next four questions? Read the question and answer.
So 5 into 4, 20.
Yeah.
Say 48, 48 minus 48 divided by minus 8 is to minus 6.
Not minus 6. First, you check this rule. Minus divided by minus is a plus, right?
Sir,
So
sir
this is
6.
negative, this is negative. Negative by negative is
Sir
going to
6.
be positive. So that
6.
is 6. So first you check the signs, then you check the number. Okay, next question.
Sir 8.
8. Next.
Sir minus 49.
Plus into minus is minus. That is minus 49. Okay, Shana, very good. You can mute yourself. Rishikesh, can you give the answer next questions?
Sir,
Yes, Rishikesh.
sir, can I tell 9 to 12th?
Yeah, that's why I gave you a chance.
Yes, sir. Sir, minus 12 divided by 4.
Yes,
Sir, minus by plus is equals to minus. Sir,
yes,
minus 3.
minus 3. Next,
Sir, 5.
next,
Minus into. Sir, minus 9.
minus 9. Because positive into negative is negative.
Yes, sir.
Next,
Sir, minus 7.
very good, Rishikesh. You can mute yourself. Abhiday, can you answer the last four questions? Abhiday,
Sir,
yes.
can I this question?
Yeah, last four questions. Can you say the answer?
Yes, sir.
Yes, 6 divided by 6,
Sir, 1.
1. Read the question and answer.
Okay, sir. Sir, minus 35 by 5 is equals to minus 7.
No, because negative by positive is negative. Next,
Sir, 35 by minus 5 minus 7, sir.
this is also minus 7 because positive by negative is negative and 35 by 5 is 7. Next,
Sir, 27.
this is division.
Sir, 3.
Negative by negative is positive and 9 by 3 is 3. So the answer is okay.
Yes, sir.
Very good, Abhiday. You can mute yourself. So all of you, this is the way we are going to multiply or divide integers. You can make a note of them quickly. Then we will take previous year Sainik questions based on them. Yes, I hope everybody copied. Next, some important properties about natural numbers, whole numbers, and integers we are going to discuss. So, left side, I'm going to write property name, and right side, I'm going to write the operations and which type of numbers are satisfying which operations we are going to discuss. So, first, closure property. What is closure property? For example, we take closure property of natural numbers under addition operation we are discussing. So what do you mean by closure property? You take any two natural numbers and add, always you get a natural number. That's why natural numbers satisfy closure property under addition. So what are the examples that we can say? The examples are 2 is a natural number, 3 is a natural number. If you add them 5, it is a natural number. Like this, you take any two natural numbers and add, always you get a natural number. For example, 10 and 2, both are natural numbers and the answer is 12. So always the answer is a natural number. So we say that natural numbers satisfy closure property under addition. Next, we discuss natural numbers under subtraction. You take any two natural numbers and do subtraction. So it is not guaranteed that always you get a natural number. For example, 3 I am taking natural number and 7 I am taking natural number, but 3 minus 7, it is not a natural number. Not a natural number. Yeah, in integers, we know the answer, it is minus 4, but minus 4 is not a natural number. So, no, natural numbers don't satisfy closure property under subtraction. So, if you want to say no, at least one counter example you give, it is enough. So, the example I gave you, 3 is a natural number, 7 is a natural number, but 3 minus 7 is minus 4 is not a natural number. Now, what about product? Natural numbers satisfy closure property under multiplication or not. You take any natural number like 2, another natural number like 6, 2 into 6 is 12. It is also a natural number. 1 is a natural number, 8 is a natural number, and product 8 is also a natural number. 100 is a natural number, and 3 is a natural number, and product 300 is also a natural number. That means you take any two natural numbers and multiply. The product is always a natural number. So we can say that natural numbers satisfy closure property under multiplication. You can write S here. And then division. Clearly division is not satisfied. Why? Because you take 2 is a natural number and 7 is a natural number. The result 2 by 7 is not a natural number. So there is no number like 2 by 7 in the natural numbers. So the quotient when you divide a natural number by another natural number is not always a natural number. So no, the property is not satisfied. So natural numbers are not satisfying closure property under division. Next, we discuss about commutative property for natural numbers. Okay, let's take 3 is a natural number, 4 is a natural number. If you add them, you get the answer 7. You change the order like 4 and 3, then you get the same answer 7. That means changing the order is not changing the result. That means you can write 3 plus 4 is always equal to 4 plus 3. So this property is called natural numbers satisfy commutative property under addition. So we can say the answer is yes. Natural numbers satisfy commutative property under addition. What about subtraction? For example, if I take 5 natural number, 2 natural number, I want to check 5 minus 2 and 2 minus 5 are equal or not. 5 minus 3 will give me 3. Sorry, 5 minus 2 will give me 3. But 2 minus 5 won't give 3. It will give minus 3. Do you think 3 and minus 3 are equal? Not equal. So 5 minus 2 is not equal to 2 minus 5. So can we say that natural numbers satisfy commutative property under subtraction? The answer is no. Next we take multiplication. You take any two natural numbers and multiply and reverse the order and multiply. You get the same result. For example, 3 and 5 are natural numbers. I'm reversing the order. 5 threes are 15, 3 fives are 15. So both are equal to 15. So that means changing the order is not changing the result. So we can say natural numbers satisfy commutative property under multiplication. So this is yes. You take any two natural numbers and multiply in any order, the result won't change. Division, clearly it is wrong. Why? Because 7 will take divisible numbers if possible, like 6 divided by 2, 2 divided by 6. Definitely they are not equal. Why? Because 6 divided by 2 is simplifying to 3 and 2 divided by 6 is 1 by 3. So do you think they are equal? Not equal. So not satisfied. So we can say that natural numbers don't satisfy commutative property under division. No. Next, associative property. What do you mean by associative property? See, something, we'll take one example. Suppose I called 3 different students, like student A, student B, and student C. I'm asking them to solve what is 1 plus 2 plus 3. Student A is adding 1 and 2 first, and he got 3. Then for this 3, the remaining number 3 is adding 3 plus 3 is equal to 6. So the final answer he got 6. Student B, what he did, like student A, 1 plus 2 is equal to 3. He did not do 1 and 2 sum first. He did 2 and 3 first. 2 plus 3 he got 5. 5, the remaining number 1 he added and we got 6. So he also got the same answer. Then student C, he didn't add 1, 2 or 2, 3. He added 1, 3. So 1 and 3 are added and he got 4. The remaining number 2 added later and he got 6. So you can see student A, student B and student C. Irrespective of first two number selection, final answer is going to be same. So this is called associative property. So what is student A doing? Student A is doing this. That is, first he added 1 and 2, that is represented by a bracket. Then later he added 3. What is student B doing? Student B is adding 2 and 3 first, then later it is adding to 1. So we can say these two are always equal. And student C, 1 and 3 are added first and 2 added next. That means this type of property, 1, 2 added first and added to 3, 2, 3 added first then added to 1 will always give the same answer. So this is called associative property. So natural numbers satisfy associative property under addition. So you can say the answer is yes. Next, subtraction. Let's take one simple example. 3, 2, 1. Okay. I want to check 3 minus 2 minus 1 is equal to 3 minus 2 minus 1 or not. 3 minus 2 we have to simplify first because it is in brackets. That is 1 minus 1. Here 2 minus 1 we have to simplify first. That is 1. 3 minus 1. Do you think that these two are equal? 1 minus 1 simplifies to 0. 3 minus 1 simplifies to 2. They are not equal, not equal, not equal. So we can say that natural numbers are not satisfying associative property under subtraction. So let's write here no. Multiplication, yes, they will satisfy. For example, I'm taking 3 numbers 3, 5 and 2. First I want to multiply 3 and 5, then multiply 2. Here first I want to multiply 5 and 2, then multiply by 3. Let's check we get the same answer or not. 3 5s are 15 into 2. Here 3 5 2s are 10, that is 3 into 10. 15 2s are 30, 3 into 10 also 30. Equal, equal, equal. So because you take any 3 numbers and you take any 2 numbers first and multiply the third later, the answer is going to be same. So we can say natural numbers satisfy associative property under multiplication. Yes. So division you can take example and check, you will not be getting satisfied. No. So we discussed closure, commutative and associative property for natural numbers under all the 4 operations: addition, subtraction, multiplication and division. And you need to remember one more thing. Commutative property is also called order property, and associative property is also called grouping property. Why? Because we are grouping any two and we are doing the operation with the third one later. So commutative property is also known as order property. Associative property is also known as grouping property. So in natural numbers, all these properties, any doubts are there, you can raise a hand. Then we'll move to whole numbers and integers. Any doubts still here? You can raise a hand. Rishikesh, you had any doubts?
Sir,
Yes.
sir, I can't understand the closure property.
Closure properties, you take any two natural numbers, Rishikesh.
Okay, sir.
Any two
2
natural
and 3.
2 and 3. Okay, you want to check which operation? Addition, subtraction, multiplication, or division?
Sir, addition.
What is the sum of 2 and 3?
6.
Sum of 2 and 3.
Sir, 6. 5, 5.
5. So 5 is a natural number.
Yes.
Like that, you take any two natural numbers and add. Always you get a natural number or not?
Sir, minus and divide, no, sir.
I'm asking about addition first.
Sir, yes.
You add any two natural numbers, always you get a natural number, yes or no?
Yes.
That's why we say that natural numbers satisfy closure property under addition. Or in other words, we also say natural numbers are closed under addition. What do you mean by closed under addition? They satisfy closure property. Okay?
Okay, sir.
Okay. Next. Jashvi, you raised the hand and moved it back. You have any doubt? So students, you have any doubt till natural numbers, you can raise a hand. Otherwise, Surya, you have any doubt? Surya,
Sir,
you have any doubt?
sir, if my subtraction no means divided also no. Division.
Don't try to compare the operations. Subtraction you see separately and division you see separately. So
Oh, sir.
numbers are not satisfying under subtraction and under division also. So we will check whole numbers. Jashvi, you raise the hand. We'll load it again. Jashvi?
Sir, I has doubt, but I cleared now.
Okay, no problem. Abhiday? Abhiday?
Sir, I didn't understand the commutative property in natural numbers.
Okay, for which operation?
Sir, division.
Division. You take any two natural numbers. Tell me two natural numbers, Abhiday. Any two.
Sir, 6 and 3.
6 and 3. So first we write 6 divided by 3 like this. Then we change the order and write 3 divided by 6. Do you think that they are going to be giving equal answers?
No, sir.
6 divided by 3 is 2. And 3 divided by 6 is 1 by 2, right?
Yes, sir.
Are they equal or not equal?
Sir, not equal.
That's why they don't satisfy commutative property under division. Okay? Okay, Abhiday. So I hope all the doubts are clear. Now we can start whole numbers. Whole numbers are same as natural numbers for closure property. You take any two whole numbers and add. Always you get a whole number. So whole number satisfy closure property under addition. Under subtraction, no. Why? Because you take two whole numbers like 3 and 7. 3 minus 7 is minus 4. But minus 4 is not a whole number. Multiplication, yes, they do. You take any two whole numbers and multiply, always you get a whole number. Division, no. For example, I'm taking 2 and 7. 2 is a whole number, 7 is a whole number. If I divide, I'll get 2 by 7. But 2 by 7 is not a whole number, no. Commutative property, addition, yes. Subtraction, no. Multiplication, yes. Division, no. So same as natural numbers, you can check by taking some examples. And associative property, same as natural numbers, that is addition yes, subtraction no, multiplication yes, division no. Next, integers you can check. Now closure property under addition, yes, you take any two integers and add, always you get an integer. You see, for natural numbers subtraction is no, for whole numbers subtraction is no, but for integers is going to be yes. Why? Because you take any two integers and subtract, always you're going to get an integer. For example, 2 minus 5 I'll do, 7 minus 2 I'll do, minus 3 minus of minus 9 I'll do, minus 3 minus 9 I'll do. So any two integers you take and let us check the answer is going to be integer or not. 2 minus 5 is minus 3, integer. 7 minus 2 is 5, integer. Now let us open the brackets here, minus 3. minus of minus is going to be plus. So minus 3 plus 9 is going to be 6. This is also integer. Minus 3 minus 9 is minus 12. This is also integer. That means you take any two integers and subtract. Always you are going to get integer only. So the answer is yes. And multiplication, obviously, yes. You take any two integers and multiply, you get integers only. But division, you take any two integers, like I'm taking 5 and 6. 5 is integer, 6 is integer. But 5 divided by 6 is not an integer. Commutative property under addition, yes. Subtraction, no. Multiplication, yes. Division, no. Associative property for integers under addition, yes. Multiplication, no. I'm sorry, subtraction, no. Multiplication, yes. And division, no. So you can see natural numbers, whole numbers, and integers are having the similar type of properties, except for closure property under subtraction. No, no, yes. This is the only difference, and remaining all the properties are acting same. So you can remember this. Until here, any doubts are there, you can ask. Surya, have any doubts? Surya?
Sir,
Yes, Surya.
sir, I don't understand closure division method. Closure property division method in integers, sir.
Come again, which numbers? Whole numbers?
Sir, integers.
Yeah, integers property name.
Sir, closure.
Under which operation?
Sir, division.
Division. You take any two integers, Surya.
Sir, 2 and 3.
4 and 3. Find their quotient, 4 divided by 3. What is the answer? 4 divided by 3?
1.333.
Is that an integer?
No, sir.
So that's why they are not satisfying closure property. Okay. Mayuk, you have any doubts? Mayuk?
Sir,
Yes, Mayuk.
I have a doubt.
Copy this table. Yes, Mayuk.
The integers communicate to division.
Come again.
Same integers communicate to property in division.
Commutative property division. Okay, let us take any two integers. Can you tell me two integers, Mayuk?
So minus 2 and 2.
Minus 2 and 2. First I divide like this, then I change the order and divide like this, and let us check we get the same answer or not. Okay, so we're getting minus 2 by 2, 2 by minus 2. This is minus 1, this is minus 1, this is true. Okay, but we say a property is satisfied when it is satisfied for all the numbers, but not only for few numbers. For example, if I take 5 and 3, 3 and 5, so we are getting 5 by 3 and 3 by 5. Do you think that they are equal?
Sir, no.
No, that means for some numbers it is satisfied, for some numbers it is not satisfied. Then you are going to say that the property is satisfied for all numbers, all integers? No, that means we say that a property is satisfied only when it is satisfied for all the numbers, not only few numbers. Okay?
Okay.
Abhyuday? Abhyuday, you have any doubts?
Yes, sir.
Tell me.
Sir, associative property integers division.
Yeah, division. You can take example, no? Tell me three integers, Abhyuday.
Sir, 3.
Any three integers I want.
Sir, 12,
12,
2, 3.
12, 2, 3. So first I will group these two and then divide by 3 later. Then I'm grouping 2 and 3, that dividing 12. Okay. So first bracket we need to simplify. 12 by divided by 2 is 6 divided by 3. 12 divided by 2 by 3 we can write like this. And 6 divided by 3 got the answer 12. Sorry, 2. And fraction, division become multiplication, this become 3 by 2. 2 6 are 12 and this is 18. Do you think 2 and 18 are equal?
No, sir.
That's why they are not satisfied. Okay.
Okay, sir.
And Manaswini, Manaswini,
Sir,
yes, Manaswini.
sir, I didn't understood associative property.
Associative property means you take any three numbers. If you group first two or last two, do the operation, you should get the same answer. For Abhiday, I took one example now. You
Oh,
understood that?
yes, sir.
I'll take one simple example. That is, for example, you want to add 2, 3, 4. Okay?
Okay, sir.
Which two you want to group first? Suppose you want to group 2
What?
and 3, or you want to group 3 and 4.
2 and 3, sir.
If you group 2 and 3, the remaining number is 4. If you group 3 and 4, the remaining number is 2, right?
Yes, sir.
Whichever are grouped, they should be done first. 2 plus 3 is going to be 5 plus 4. So here 3 plus 4 is 7. That is added to 2. So 5 plus 4 is giving 9. 2 plus 7 also giving 9. Are we getting same answer or not?
Yes, sir.
That means any two you group first, you are going to get same answer in addition, right? That's
Yes, sir.
they're satisfying in addition. All type of numbers are satisfying in addition. Yes, yes, yes. Okay.
Sir, it did not satisfied in division.
Division not satisfied. I took one example for Abhiday just now asked. I took example. Even for subtraction also you can take. They're not satisfied. Okay.
Okay, sir.
But multiplication satisfied. Sahana. Sahana. Sahana, you are not audible. Let me know in the chat box what you want to ask. Jashvi. Jashvi.
Sir,
Yes, Jashvi.
I didn't understand in whole numbers close
Closure property. Which operation?
addition.
Jashvi, take any two whole numbers.
Mm, 3 and 4.
3 and 4. You want to check closure property or commutative property?
Closure property.
3 and 4. If you add 3 and 4, what is the answer?
7.
7 is a whole number or not?
Yes, sir.
Not only 3 and 4, you take any two whole numbers and add. Always you are going to get a whole number or not.
Yes, sir. I
That's
get
why you
full.
say that whole numbers satisfy closure property under addition. Okay?
Okay, sir.
Vishwajit?
Sir,
Sahana, you are asking me to, can we copy this table? Yes, you must copy. Yes,
okay.
Vishwajit, what is your doubt?
I copy this table.
Yeah, you have to copy. That is your doubt.
Yes, sir.
Okay, you have to copy. Copy quickly. Yes, I hope everybody copied, and we'll move to the next properties. Okay, students, we're going to discuss distributive property next. So there are two types of distributive properties we are going to discuss: multiplication over addition or subtraction, division also over addition or subtraction. See, First, I'm going to discuss this, whether this is satisfied or not. Do natural numbers satisfy distributive property, multiplication over addition? Okay, we'll take 1, 2, 3 multiplication over addition like this, or even we can take like this, 1 plus 2 into 3. Okay, so this is called, the first one is called left distributive property. Why? Because the single term is there on the left, and this is called right distributive property. Why? Because the single term is there on the right. If the single term, the lone term is there on the left, it is called left distributive property. On the right, it is called right distributive property. So let us check what is this distributive property. This single term will be distributed to all the terms inside the bracket. That means 1 into will be distributed to 2 as well as 3. So we can write 1 into 2 plus 1 into 3. So what happened? This 1 into is distributed to 2 as well as 3. That's why it is called distributive property. So 1 into is distributed to 2, 1 into distributed to 3. This is why it is called distributive property. So let us check it is correct or not. First I am solving LHS. 2 plus 3 is 5, and let us do 1 to 5. 1 into 2 is 2, 1 into 3 is 3. So 1 into 5 we got 5, 2 plus 3 also 5. So we got LHS equal to RHS. Yes, it is satisfied. Now we'll take right distributive property. What is right distributive property? The single term is there on the right. Now let us distribute this into 3 to all the terms inside the bracket. So this into 3 is distributed to 2 as well as 3. So what you will get? So we'll be getting 1 into 3 plus 2 into 3. So first let us solve what is there in the bracket for LHS. 2 plus 3 is 3 and this is 3. 1 into 3 is 3, 2 into 3 is 6. 3 3s are 9, 3 plus 6 is 9. So we got the same answer. That means we checked by taking one random example. Left distributive property is satisfied, right distributive property also satisfied. So we can say the answer is yes, it is satisfied. So any doubts in this property you can ask. Rishikesh, you have any doubts?
Sir,
Yes.
sir, we have to copy this table separately.
Yes, separately, not in the previous table. This is a separate table.
Okay, sir.
Okay. So any doubts you have, Rishikesh, in this?
Sir, no.
Next, we are going to discuss multiplication over subtraction. Sharath, you have any doubts? Sharath?
Sir,
Yes, Sharath.
sir, below the table, left and right, that also copy.
Yeah, if you have time, you can copy. There, you can not only you can copy this, you can take your own example and you can try. This is only checking. Okay.
Okay, sir.
I took 1, 2, 3. No, you can take any 3 numbers and you can check. Okay.
Okay, sir.
Mayuk.
Sir,
Yes, Mayuk.
sir, today what class you are taking?
After 7:30, I'm going to take GK. See, every week the schedule will be same. Monday, Tuesday, GK. Next 2 days we have English, and next 2 days we have intelligence. GK, English, intelligence. Okay.
Okay.
So because today Monday we are going to take GK. So next, let us check the next property: multiplication over subtraction. Now, multiplication over subtraction, we'll take an example. Some random numbers, natural numbers I'll take, like 5, 2, and 7. So what I do is, first left distributive property we will check, that is 5 into 2, let's take 7 here and 2 here. 5, 3, 2. Okay. So we are getting 5 into 3 minus 2. This is left distributive property because the single term is there on the left. Now the right distributive property, the single term will be there on the right. That is, we'll take 5 minus 3 into 2. So according to the distributive property, this 5 into should be distributed to both the terms inside the bracket. So you should get 5 into 3 minus 5 into 3. Let us check this is correct or not. And similarly, we are going to check this into 2 is distributed to 5 as well as 3. So that let us check 5 into 2 minus 3 into 2, correct or not. So first I am checking left distributive property. That is, first this bracket we are going to simplify. 3 minus 2 is 1. 5 3s are 15, 5 2s are 10. 5 1s are 5, 15 minus 10, 5. Yes, they are equal. That means this property is satisfied. And next, 5 minus 3 we will simplify first. That is 2 into 2. 5 2s are 10, 3 2s are 6. 2 2s are 4, 10 minus 6 is 4. So both left and right are satisfied. So we can clearly see that you can take any three natural numbers and check. Multiplication is always distributive over subtraction also. Yes. So multiplication over addition, distributive property satisfied. Multiplication over subtraction also satisfied. Sahana? Sahana?
Sir,
Yes, Sahana.
sir, this Sunday I marked out the test, sir.
Come again.
Sir, this Sunday I marked out the test.
Yesterday I have not conducted the test. I told you no. This Sunday not there. Next Sunday will be there.
Okay, sir, I don't know.
So we're done with this, and now we will check division over multiplication. So let's take the example here. Division over multiplication, satisfied or not. For example, I take 16, 4 and 2. I want to check this is, first I'll check addition. Left distributive property, 16 divided by 4 plus 2, and then right distributive property I will check, that is 16 plus 4 divided by 2. So how are you going to distribute 16 divided by 4 plus 16 divided by 2? And how you are going to distribute for this? 16 divided by 2 plus 4 divided by 2. So 4 plus 2 is 6, and this is 16 by 4 is 4. 16 by 2 is 8. So 16 by 6 is clearly not equal to 12. This is going to be a fraction, but this is going to give 12. So left distributive property not satisfied. Let us check the right one. So 16 plus 4 is 20 by 2 is equal to 16 by 2 is 8, 4 by 2 is 2. So we're getting 10 equal to 10. That means only right distributive property is satisfied and left is not satisfied. So we can say only right distributive property will be satisfied. Similarly, you take division over subtraction also, then also you'll get the same answer. Only right distributive property will be satisfied, but left will not be satisfied. But for multiplication over addition and subtraction, both left and right are satisfied. So even you can check whole numbers and integers also same. Yes, yes, only right, only right. Yes, yes, only right, only right. So you can copy this table, and if you want to take, you can copy the examples also. But no need of taking the same examples. You can take your own examples and check whether they are satisfied or not. So division also distributive over addition and subtraction, but only in the right manner, not in the left manner. Copy the table. Nishil? Nishil?
Sir, can I write this process also?
Come again?
Sir, can I write this process also?
Yes, example, what is said. No need to take the same example. You can take your own examples and you can try whether it is correct or not.
Okay, sir.
Yes, Nishil?
Sir, I suddenly touch it.
Snehal? Snehal?
Sir,
Doubts?
sir, voice is resounding, sir, your voice.
Snehal, you have any doubt?
Sir, your voice is resounding.
Snehal, you try to leave the class and join again. Okay, we are going to continue the next property. So here I'll write the property name and write natural numbers, whole numbers, integers. Okay, first additive identity. What do you mean by additive identity? To any natural number, if you add one number, same number should come as the answer. What is that? Zero. So additive identity is zero. Is it existing in natural numbers? No. There is no additive identity in natural numbers because there is no zero in natural numbers. But whole numbers it is there and integers also it is there. Suppose there is a number called a. If you add 0, either a plus 0 or 0 plus a, both are equal to the same number again. That's why 0 is called additive identity. 0 additive identity is not there in natural numbers, but it is there in whole numbers and integers. And then additive inverse. What is additive inverse? You take any number, which number you have to add to a so that you get the additive identity 0. So the question mark should be replaced by minus a. So for every natural number, there is no negative number. For example, you have 2, but there is no minus 2 in the natural numbers, you can write no. Whole numbers also, for example, you take 2, but there is no minus 2 in the whole numbers, so no. But integers, you take any integer, the negative of the integer will always be there, that is yes. So you take 2, minus 2 will be there. You take 4, minus 4 will be there. Suppose you take minus 4 you add how much to get 0? So that question mark should be plus 4. That means minus 4 additive inverse is plus 4. So is plus 4 there in the integer? Yes. For plus 4, minus 4 is there. For minus 4, plus 4 is there. So additive inverse property, the existence of additive inverse is there in integers. Next, multiplicative identity, that is nothing but 1. That means you take any number like a multiplied by 1. It is also like 1 into a, both are equal to a. So we can say this 1 as the multiplicative identity. Multiplicative identity. So 1 is there in natural numbers, you can write yes. Whole numbers also it is there, yes. Integers also it is there, yes. So we can write. And then multiplicative inverse. For example, I take a natural number 3. I want to multiply by any natural number to get the multiplicative identity 1. So is there any natural number possible here? We cannot take any natural number here so that the product is 1. That means the existence of multiplicative inverse is not there in natural numbers, so we can write no. Whole numbers. Even whole numbers also same problem because 3 is a whole number. I want to multiply 3 by any whole number. I want to get the answer 1. So is there any multiplicative inverse for whole numbers? No. Even for integers also we don't have. Why? Because 1 by 3 is not an integer. But in further classes we are going to learn rational numbers denoted by the letter q. There this property is going to be yes. But in your syllabus rational numbers is not there, but you can just remember up to integers no set is satisfying multiplicative inverse. And there are some other names of this additive inverse is also called negative. Additive inverse is also called negative. Multiplicative inverse is also called reciprocal. Is also called reciprocal. Additive inverse, negative, both are same. Multiplicative inverse, reciprocal, both are same. So these are the properties: additive identity, additive inverse, multiplicative identity, and multiplicative inverse. You can copy this, all of you. And any doubts, you can raise a hand. Mayuk? Yes, Mayuk?
So can you give example of multiplicative inverse in rational numbers?
Actually, rational numbers are not there in your syllabus, no? 2 by 3 is called a rational number. The reciprocal of 2 by 3 will be 3 by 2. So it is also there in the rational numbers. You need not learn about rational numbers in your syllabus. Up to integers is enough. Surya,
Sir, sir, in property second additive inverse 3D solid.
come again.
Sir, in additive inverse.
Yes, additive inverse.
Sir, additive to 3D solid.
3 digits.
Sir, D. Sir, D.
D. 3 Ds.
Yes, sir.
What 3 Ds? Surya, I didn't get your question.
Sir, you wrote a spelling mistake, I think.
Spelling mistake, okay.
Sir, I didn't understand additive inverse natural numbers.
Additive inverse. Additive inverse. Natural number. Surya, you take any natural number?
Sir, 3.
3. 3. Which number you will add to 3 so that you will get the answer additive identity?
Sir, can't find.
Actually, minus 3 is the answer, right?
Yes, sir.
Because 3 plus minus 3 is going to be 0. But is there any number called minus 3 in natural numbers?
No, sir.
That's why it is not satisfied. Okay.
Okay, sir.
Nishika. Nishika.
Sir.
Any doubts?
Yes, sir.
Tell me.
Sir, I didn't understand multiplicative in reverse. Inverse.
Multiplicative inverse, that means suppose you take the same number 3. Okay. 3 you multiply by which number you want to get the answer 1, because 1 is the multiplicative identity. Can you tell me the answer? 3 multiplied by which number is 1? 3 into 1 is 3. No, I want 1. So the answer is 1 by 3. Yes, Nishika?
Yes, sir.
Because 3 get cancelled, answer is 1, right?
Yes.
But is there any number called 1 by 3 in the set of natural numbers?
No, sir.
Is there a number called 1 by 3 in the set of whole numbers?
Sir, yes.
Whole numbers, you have 1 by 3. Not there. What are whole numbers? 0, 1, 2, 3, and so on. But 1 by 3 not there.
No.
Integers, is it there?
Sir.
Integers also not there. Because you have 0, -1, -2, -3, 1 to 3, and so on. That's why no, no, no for all the 3 sets. Okay?
Okay, sir.
Aryan?
Sir,
Yes, Aryan.
sir, I did not understand anything about additive identity, additive inverse.
Additive identity is nothing but you take any number. Tell me one number, Aryan. Any,
Sir,
nat-
2.
any natural number.
Sir, 2.
2, which number you add so that the answer is 2 only again.
0.
That's why 0 is called additive identity. Okay?
Yes. Sir,
What?
if it does not have a natural number, it is not.
That's why, yes, because 0 is not a natural number. No, natural numbers are not having additive identity. Okay?
Okay, sir. Sir, additive inverse?
You take any natural number.
Sir, 10.
10. 10. You'll add which number to 10 so that the answer is equal to additive identity 0.
Sir, it is not possible.
Actually, -10 is possible, right? 10 plus -10 is 0.
It is not a natural number.
Yes, but -10 is not found in natural numbers. That's why answer is no. Okay?
Okay, sir.
Whole numbers also it is not found, but it is found in integers. That's why it is no, no, yes. Is it clear?
Yes, sir. Clear, sir.
Arush, you have any doubts? Arush? Arush, you are not audible to me. Arush, can you leave the class and join again? Or you let me know in the chat box what you want to ask. Rishikesh?
Sir,
Yes, Rishikesh.
sir, it glitched.
Come again.
Sir, it is glitched.
Arush?
Sir, my mic was not working. Sorry, sir.
Now you are audible. Tell me.
Can you explain multiplicative identity, sir?
Multiplicative identity means, for example, we take natural numbers. Take any natural number, Arush.
Sir, 1 and 3, sir.
One natural number. Any one natural number.
1, sir, 3.
3. 3 you multiply by. You are asking about multiplicative identity or multiplicative inverse?
Identity, sir.
3 you want to multiply by which number so that the answer is multiplicative. The same answer 3.
Sir, 1.
1. That's why 1 is called multiplicative identity. Okay?
Okay, sir.
So any number multiplied by 1, answer is same result. That's why 1 is called multiplicative identity.
Multiplicative
Yeah,
identity.
Arush?
Okay, sir. My doubt is cleared.
Okay. And then, okay, these are the properties that we discussed in this chapter. Now we're going to solve the questions based on the properties. I hope everybody copied all the properties, right? Manaswini,
Sir, I didn't understand multiplicative inverse.
multiplicative inverse. Tell me any natural number, Manaswini.
Sir, 9.
9. 9 you multiply by which number so that the answer is multiplicative identity 1. We learned multiplicative identity is 1, right?
Yes, sir.
9 you want to multiply by which number so that the answer is 1?
Sir, we cannot sir.
Answer is 1 by 9. 9 into 1 by 9 is 1 or not?
Yes, sir.
Because 9 cancels, answer is 1, right? Yes?
Yes, sir.
Now tell me, is there any number called 1 by 9 in the natural numbers?
No, sir.
Is there any number called 1 by 9 in the whole numbers?
No, sir.
Integers?
No, sir.
That's why these three properties are not satisfied. No. That means natural numbers are not satisfying multiplicative universe. Whole numbers are not satisfied in multiplicative universe, and integers also no. Okay?
Additive universe means
Additive universe satisfied for integers. For example, you want to check in which set, tell me, natural number, whole number, or integers?
sir,
What?
sir, whole number, sir.
Okay,
Whole
whole
number.
number. Tell me one whole number, anything.
0.
0. Yeah, for 0 it exists because 0, which number you add so that the answer is 0.
Yes, sir.
What is the answer?
0.
0. So 0 is there in whole numbers, right?
Yes, sir.
We need to check other numbers also. Tell me one
Yes,
other whole number.
sir. 5.
5. 5 you will add which number so that the answer is additive identity 0.
Sir,
5, which number we have to add so that the answer is 0. Is it minus 5, Manaswini?
yes, sir.
Because 5 minus 5 is going to be 0, right?
Yes, sir.
But is minus 5 found in whole numbers?
No, sir.
That's it is not satisfying. But integers it will satisfy because in integers minus 5 will be there, right?
Yes, sir.
Is it clear?
Yes, sir.
Okay, let us solve some problems based on these properties. These are the previous year questions we have on the properties. Yes, this question first. So all of you try this question. This question came in 2022 paper. Select the values of mn to make the statement true. Anyone want to give the answer can raise a hand. Varshita, you want to give answer? Varshita?
Sir, we have to distribute 127 into two parts.
Okay. So first let me write that equation. So they said 127 into 15 is equal to m into 15 plus n into 15, right?
Yes, sir.
Okay, here which property we can apply on the RHS?
The distributive property.
Distributive property. So which is common here?
Sir, 15.
15 is common. So can we take common and write 127 into 15 is equal to m plus n into 15 according to distributive property. Can I write like this?
Yes.
Okay, now you compare LHS and RHS. Now we can write m plus n should be equal to 127.
Yes.
So which option is satisfying this equation? M plus n is equal to 127.
Sir, option D.
Option D. You also said the same answer, right?
Yes.
So we need to depend on options. Answer D is correct because 100 plus 27 is 127. Good version. So if you can copy this now. Nishika, Mayuk, Mayuk, you wanted to give answer.
Yes, sir.
Okay, you got the same answer, Mayuk.
Yes, sir.
Okay. I hope everybody copied. Next question. All of you try the next question. Whole numbers are closed under which operation? Very simple question. Whole numbers are closed under which operation? Mayuk, can you give the answer?
Very multiplication.
Whole numbers are closed under subtraction.
So no.
Can you give one counter example?
Plus 0, 1, 1 minus 0 is equal to minus 1.
1 minus 0
1
minus
minus,
1.
no, sir. So 1 minus 0 equal to 1. But 0 minus 1 equal to minus 1, not a whole number.
You're checking commutative property. They're asking closure property. Closed. The word closed. The word closed indicates closure property. Check closure property. You are checking commutative property. You take any two whole numbers and subtract, and you check the answer is a whole number or not.
0 minus 1, not a whole number.
Minus 1, it is not a whole number. So subtraction not satisfied. What about division? Division also not
So 5
satisfied.
by
You
5
put
by
two
3.
whole numbers and multiply. Always the product is a whole number, right?
Yes, sir.
So answer C, multiplication. Very good, Mayur. You can mute yourself.
Okay, sir.
Shall I have you completed?
Sir?
Have you completed copying?
Sir, yes, sir.
Okay, we'll move to the next question. Aryan,
Sir,
completed?
sir, yes, sir.
All of you try this question now. In the morning, the temperature was minus 10 degrees Celsius and it decreased 3 degrees by the evening. What was the temperature in the evening? Who will try to say the answer? Sharif, can you give the answer?
Sir, no, sir, but zoom the question.
Shall I zoom the question?
Yes, sir.
Is this okay?
Okay, sir.
Manaswini, can you give the answer for this?
Sir, option C, sir.
Option C. Can you explain, Manaswini, how you got the answer?
Sir, in the morning the temperature was minus 10 degrees Celsius, sir.
Okay.
It has decreases 3 degrees, sir.
Decrease 3 degrees means add 3 or minus 3?
Minus 3, sir.
What is minus 10 minus 3, Manaswini?
Minus 10 minus 3, minus plus minus 13.
Minus 13. Which answer is correct?
Option C, sir.
Very good, Manaswini. You can mute yourself. So, Manaswini got the answer. That is option C, correct answer. Copy this question. Arush. Arush, you wanted to give the answer. Arush, you're not audible. Let me know in the chat box. Nishika. Nishika.
Sir,
Yes, Nishika, why did you raise your hand?
sir, your voice is talking again. I
Nishika,
checked my.
can you leave the class and join again?
Okay, sir.
Okay, all of you, I hope you have copied. We'll move to the next question now.
Check your answer.
Okay, we'll stop this and we will start new chapter tomorrow in maths. So next, let's start with GK. In GK, we are taking today's topic is scientific devices. Okay, today's topic for GK is different types of scientific devices used in daily life. All of you try to answer these questions now. So this is a simple question that we were answering in many exams. Students, just wait a second. I hope everybody is able to see the question now. So this is the question. Which scientific device is used to measure atmospheric pressure? All of you participate in the poll. Which scientific device is used to measure atmospheric pressure? Thermometer, barometer, anemometer, hygrometer. Everybody participate in the poll and give your answer. Time up. A barometer is a device used to measure atmospheric pressure. It helps in weather forecasting as changes in air pressure indicate different weather patterns. So the answer is B. B is correct answer. Next question. All of you be ready. Very, very simple question. Here is the next question. What is the primary function of a thermometer? Option A, measuring speed. Option B, measuring temperature. Option C, measuring air pressure. Option D, measuring humidity. And time up. Surprisingly, students gave wrong answer. One student said option D, one student said four students said option C, and two students said option A wrong. But majority of the class gave correct answer. Option B is correct, measuring temperature. So why thermometer we use? To measure temperature. Measuring temperature is the answer. A thermometer is a device used to measure temperature. It can be based on mercury, alcohol, or digital sensors to detect temperature changes. Next question. Which device is used to measure humidity in the air? Option A, anemometer, option B, barometer, option C, hygrometer, and option D, pyrometer. Time up. Two students said barometer. Just now we discussed barometer is used to measure pressure, but still gave the wrong answer. 6 students said anemometer, wrong answer. And pyrometer, nobody gave the answer. 12 students said correct answer, hygrometer is the correct answer. Option C. A hygrometer is an instrument used to measure the moist content. Moist content means humidity, how much water presence is there in the air. It is commonly used in weather forecasting and indoor climate control. Next question. Yeah, this is your next question. Which device is used to measure the speed of the wind? Tachometer, anemometer, barometer, chronometer. Thank this question, all of you participate in the poll. Students, one more important thing. So majority of the students are asking after 8 o'clock, you're not getting the enough time to come to school to get ready by 9 o'clock if the class is up to 8 o'clock. So tomorrow onwards, the online class will be from 6 to 7:30. So 6 to 7, regularly we'll take maths for 1 hour, and 7 to 7:30, the other subject will take. First 2 days of the week, GK, next 2 days, English, and last 2 days, intelligence. So tomorrow onwards, the online class timings are up to 7:30, 6 to 7:30. Okay, who gave the correct answer? 14 students gave the correct answer. Anemometer is the correct answer. Answer is option B, anemometer. An anemometer is a device used to measure wind speed. It is commonly used in meteorology to study wind patterns and weather forecasting. Next question. Simple question. Which device is used by doctors to listen to the sounds of the heart and lungs? Option A, sphygmomanometer. Option B, stethoscope. Option C, endoscope. And option D, microscope. But I just connected with my mobile. So option B, that is, how many students gave the correct answer? Option B, 18 students. Stethoscope, that is the correct answer. So answer is stethoscope. Option B. A stethoscope is a medical instrument used by doctors to listen to internal body parts sound, such as the heartbeat and lung sounds. It helps diagnose heart and respiratory conditions. Next question. What is the function of a sphygmomanometer? Option A, measuring blood pressure. Option B, measuring pulse rates. Option C, measuring oxygen levels. And option D, measuring sugar levels. What is the function of a sphygmomanometer? Option A, measuring blood pressure. Option B, measuring pulse rates. Option C, measuring oxygen levels. And option D, measuring sugar levels. Time up. Two students said option D, measuring sugar levels. Wrong answer. Three students said option C, measuring oxygen levels. Wrong answer. Four students said pulse rate. Wrong answer. And 10 students gave correct answer. That is measuring blood pressure. So blood pressure is measured by an instrument called sphygmomanometer. So the correct answer is option A. A sphygmomanometer is a device used to measure blood pressure. It consists of an inflatable cuff, a pressure gauge, and a stethoscope or digital sensor. So nowadays you can see in most of the hospitals also when you visit for OP, so outpatients, first they take your blood pressure reading by sphygmomanometer only. Next question. Which instrument is used to measure electric current? Voltmeter, ammeter, ohmmeter, galvanometer. Time up. One student said ohmmeter, wrong answer. Two students said galvanometer, wrong answer. Five students said voltmeter, wrong answer. And the correct answer is given by 13 students. Ammeter is the correct answer. The correct answer is option B, ammeter. An ammeter is a device used to measure electric current in a circuit. It is connected in series with the circuit to provide accurate readings. So there are two types of connections possible in a series, in a circuit, either series or parallel. So you may get a question like ammeter is connected in the circuit via which type, that is series or parallel. Answer is series. Next question. Which device is used to measure the purity of milk? Option A, lactometer. Option B, hydrometer. Option C, picnometer. And option D, colorimeter. You can participate in the poll now. Lactometer, hydrometer, picnometer, and colorimeter. Time up. And one student said calorimeter, wrong answer. 5 students said hydrometer, wrong answer. And correct answer is given by 14 students. Lactometer is the correct answer. Option A, lactometer. A lactometer is a device used to measure the density of milk, which helps determine its purity and whether it has been adulterated with water. So you can check the purity. Next question. Which device is used to measure the density of liquids? Hydrometer, hygrometer, pyrometer, voltmeter. Time up. 5 students gave voltmeter, 6 students said hygrometer, and 9 students said hydrometer. So that is hydrometer is correct answer. Correct answer is option A, hydrometer. A hydrometer is a scientific instrument used to measure the or relative density of liquids. It is widely used in industries such as brewing and winemaking. So, last question of today's class. What does a seismograph measure? Option A, atmospheric pressure. Option B, earthquakes and seismic waves. Option C, wind speed. And option D, ocean depth. Time up. One student said wind speed, wrong answer. Two students said ocean depth, wrong answer. Four students said atmospheric pressure. Atmospheric pressure already we discussed today's class, barometer, wrong answer. So 12 students give the correct answer, earthquake and the seismic waves. Option B. A seismograph is an instrument that records the intensity, duration, and the frequency of earthquakes. It helps scientists study tectonic movements. So, due to the tectonic movements below the Earth's surface, we get earthquakes. That is measured. How intense it is. It is measured by a seismograph. So, all the students, thank you for joining. That's it from today's class. You may leave the class now. So, tomorrow onwards, the online class timings are morning 6 to 7:30 only, so that you get enough time to get ready for school. You may leave the class now, all of you.